We would now like to start 5G International Workshop on the latest trends in industrial use, 5G communications spreading dreams on land, sea, sky, and space. I am Tamami Kodemura, and I'll be serving as the moderator of today's session. Thank you. In this workshop, simultaneous interpretation will be available. Please use the receivers that were provided to you at the reception. You will be able to hear Japanese on channel 1 and English on channel 2. First of all, I would like to ask the Director General of Telecommunications Bureau of Ministry of Internal Affairs and Communications, Mr. Hironobu Yumoto, to deliver an opening speech. Over to you, Mr. Yumoto.
はい、ただいまご紹介い
Thank
た
you
だき
very
ま
much
し
for the
た
kind introduction. My name is Yumoto from Telecommunications Bureau of Ministry of Internal Affairs and Communications. Thank you very much for your continued understanding and support to the Radio Wave Administration. Today,
開催されまして、大変多くの方々に
we have a large number of people attending the 5G International Workshop today, and I would like to express my greatest appreciation as a core organizer of the event. And also,
フォーラムにつきましては
in terms of XG Mobile Promotion Forum, which was launched in April of this year, co-chair Dr. Morikawa is attending, and also Mr. Nakao is also attending the meeting. And I would like to express my sincere gratitude to all of you in supporting promotion of 5G. In terms of XG Mobile Promotion Forum, to respond to the changes in the needs of 5G, it is focused on the commercialization of 5G and also penetration of 5G, and at the same time towards beyond 5G and 6G. The intention is to exercise its leadership as Japan and to come up with new creation of new use cases and to realize innovation. I understand that is the purpose of the forum. To achieve those objectives, not limited to mobile-related companies, but also potential user companies of 5G, and as well as young, dedicated and passionate individuals. All of these stakeholders, they need to work together across the board to come up with new projects. We have very high expectation to the work of the forum. Today, a 5G International Workshop. It is titled "A Latest Trend in Industrial Use, 5G Communications Spreading Dreams on Land, Sea, Sky, and Space." The workshop will feature lectures and panel discussions by those working at the forefront of 5G development in railroads, autonomous driving, wind power generation, marine communications, drones, and HAPS.
また、より多くの皆様方にご視聴いただけるように、
So as to make sure that more people will be able to listen to the lectures and panel discussions, they will be available on demand on the official website of XG Mobile Promotion Forum, and will be streamed in English, not only in Japanese, and to reach wider audience.
さて、ご案内の通り、
Now, as you know,
2020年の我が国での 5G 商用サービスの開
since the launch of 5G commercial service in Japan in 2022, the importance of 5G has been increasing. In terms of the number of 5G subscriptions,
契約数の約 45% を占める契約まで至
the number has reached for about 45% of the total number of mobile cell phone subscriptions as of June 2024. And the coverage has reached as quite high. And in terms of the users of the mobile phones, they find it difficult to come up with a mobile environment where they can enjoy the features of 5G, which I believe is a major challenge that we are facing as of today. The Ministry of Internal Affairs and Communications
利便性の向上はもちろんのこと、
considers it is very important to realize a mobile environment in which they can experience the unique features of 5G, such as high-speed and low-latency communications. We have councils and workshops where we work to accelerate the establishment and the installation of 5G, and we are now studying the specific actions. And in July, the working group has compiled a report. And further on, allocation of additional spectrum for 5G, and also there are new needs of wanting to use the spectrum in drones. So we are now studying the possibility of realizing that. And also to maximize or leverage the millimeter wave for the high frequency band or high spectrum, we are now studying the policy for the use of the spectrum. For Japan, who is experiencing population decline, we believe that the utilization of spectrum, including high frequency spectrum, is one of the keys for sustainable economic growth, and we will continue to study this issue. The Ministry of Internal Affairs and Communications intends to promote the construction and convenient ecosystems by promoting the spread of 5G, by building an ecosystem while organically coordinating the efforts of the public and private sectors. We would like to receive your continued support. In closing, I would like to close by hoping that this event will be fruitful for all of you who are here today. Thank you very much.
Thank you very much, Mr. Yumoto. Next, we would like to invite opening remarks from the host of this workshop, XG Mobile Promotion Forum co-chair and professor of the University of Tokyo Graduate School of Engineering, Dr. Hiroyuki Morikawa. Over to you. Thank you, and good morning, everyone. I am co-chair of XGMF together with Professor Nakao. My name is Morikawa. I would like to take this opportunity to briefly introduce XGMF, the 5G Mobile Promotion Forum and the Beyond 5G Promotion Consortium integrated into XGMF, XG Mobile Communication Promotion Forum this year. And XGMF would like to work with our members to help the members to bring benefits to the members. This is our vision for XGMF. XGMF sounds neutral, sounds like it is receiving government support. So why not make good use of XGMF for the business expansion of our members? This is the concept behind the establishment of XGMF. We are very grateful to be running 20-some projects with the members as of today. Next week on Monday, there will be a project briefing. And this will be open to non-members as well, not just the current members of XGMF. So some of these projects have just started, but if you have the time, I hope that you will join us in the project briefing. Also, we will continue to work with overseas partners. So once again, I would like to stress that XGMF is for the purpose of the members and for everyone here. We would like to explore new ways of contributing, and we will very much appreciate your feedback. So XGMF introduction was my opening remarks. Thank you very much.
Thank you very much, Professor Morikawa. Now we would like to start on the program for today. The latest trends in industrial use, 5G communication spreading dreams on land, sea, sky, and space. We are going to hear from 5 speakers. The first speaker is from Central Japan Railway Company, Manager of Maglev Systems Development Division, Chuo Shinkansen Promotion Division. Mr. Yo Koide is going to speak about superconducting maglev and wireless technology. Mr. Koide, please.
はい、今日はですね、このような場をいただきまして、誠にあ
First
り
of
がとう
all,
ござい
thank
ます。
you very much for giving me this opportunity at JR's Central at the Maglev Systems Development Division. I am in charge of the development of wireless communications and other technologies. Today, in the Maglev Chuo Shinkansen and its wireless communication technology is the topic of my presentation. In the first half and the second half, we are going to speak about the followings. First, in the first half, superconductive Maglev technology and Chuo Shinkansen. In the first half and the latter half, I will touch upon the wireless communication technology. On this slide, you can see the overview of the routes of the Shinkansen. What is depicted in blue line is what is currently available for passengers on the Tokaido Shinkansen line. According to the table below, the metal train wheel based Tokaido Shinkansen in blue at the bottom, the operation speed is currently 285 kilometers per hour between Tokyo and Nagoya. It takes only 86 minutes, and the duration between Tokyo and Osaka is 141 minutes, a little more than 2 hours, connecting two big cities by Tokaido Shinkansen. Another line in red, that is called the Chuo Shinkansen. Superconductive maglev method is utilized. Based upon this technology, this line is being constructed. Operation speed is 500 kilometers per hour, much faster than the current speed. And by this operation, it's only 40 minutes between Tokyo and Nagoya, and a little over 1 hour or 67 minutes connecting Tokyo and Osaka. Therefore, the Chuo Shinkansen will be much faster than the Tokaido Shinkansen, shortening the duration of the travel time. And regarding the maglev,
でですね、中央新幹線のですね、建設
for Chuo Shinkansen, what about the current status of construction works? I would like to use these pictures to explain. On the right-hand side, starting from the Shinagawa Station, starting station in Tokyo. Now we have the Shinkansen station of the Shinagawa Station, beneath which we are constructing this underground Shinagawa Station for maglev. And it is the center of the metropolis. Therefore, we are utilizing the shield machine in order to dig. That is number 2, the first Tokyo Metropolitan Tunnel. And the next, at around the Hashimoto area, we are constructing the Kanagawa Prefecture Station, the first station after Tokyo. And according to this diagram, Yamanashi Maglev experimental line will go through this area, and after that it will get into the Kofu Basin. And in number 4, as you see, the elevated bridge is also under construction in Yamanashi Prefecture. And now towards the west, it will go through the Southern Alps mountain range, and therefore there will be tunnels to be constructed to the west. And number 6, the west side of the Southern Alps in Nagano Prefecture, now the tunnel is being created. Number 7, Tenryu River needs to be crossed by bridge, therefore bridge is being constructed. Number 8, Chubu General Train Yard close to Nakatsugawa in Gifu Prefecture. So this train yard is being constructed. Lastly, now, tentative terminal, Nagoya Station will be built underground. So just beneath the current Nagoya Station, the station is being built. So that is brief overview of the current progress of construction for Chuo Shinkansen line.
From now on, I'd like to talk about what kind of wireless communication is to be conducted in superconductive maglev. First, wireless communication. What kind of roles to be played by wireless communication in the superconductive maglev service? As I said earlier, superconductive maglev is utilizing maglevs on board and adjusting the current from the coil underground or on the ground, and then adjusting. Therefore, from the ground, the control is being applied. Therefore, there is no driver for the train. Therefore, wireless communication connecting the train cars and the ground. Therefore, the wireless communication is playing a very important role. Having said that, at the very high speed of 500 km per hour, wireless communication must be conducted. Then there are several technical challenges to overcome. Below, you can see the first and foremost, we needed to respond to Doppler shift. You may have heard the term Doppler effect. When you are moving at high speed and then you try to communicate with wireless technology, there will be the shift of the frequencies. At 500 kilometers per hour, we are not able to ignore that shift. So we have to respond to that. Otherwise, we won't be able to have appropriate communication. That is the challenge of what we call Doppler shift. Next is fading. When we say fading, when you try to establish communication with moving object like train, for example, through tunnel, on the walls of a tunnel or outdoors, you need to have a reflection against the walls of the building and so forth. And there will be interference of the wire radio waves, enhancing the levels or downsizing downgrading the levels, so that here you can see the technical challenge. You see the fluctuations of the radio wave that has been actually measured. The higher the better, but the lower, then there will be errors in the communication. That is the second challenge. The third challenge is how we are able to realize the smooth handover at 500 km per hour per second. More than between 100 and 200 meters movement will be recorded. So at the ground station, the train will pass so quickly. And therefore, we needed to consider how smoothly handover can be done between ground stations. Although there are such technical challenges, but utilizing millimeter waves will be utilized in order to provide a high-quality, reliable wireless communication system that has been developed. So let me briefly introduce what it is. First of all, you may think that this is quite a lengthy line. In the communication area, when the communication is utilized in the trains, and the trains are supposed to move along the fixed rails or tracks, so you may think that you are able to create a very lengthy, narrow route. Therefore, you are able to have a directional antenna. Therefore, you don't have an omnidirectional antenna. You are able to have a directional antenna in order to disseminate, send the communication far away. So by doing this, you are able to extend the propagation distance as much as possible. So this shows what we are utilizing actually in the Yamanashi experimental line. The picture shows the millimeter wave train radio system. In the left and the middle, this is the ground stations, and there are 4 antennas on the left side wall of the tracks. And in the middle, the pillars is built in order to provide the 4 antennas. I think you are able to see 4 antennas for both, and 2 are communicating towards the depths, and in the proximity, 2 antennas are communicating with the proximity area. So 2 each for one direction. As I explained, in order to respond to the fading problem I explained earlier, so by having these 2 antennas with a little distance between each, if you have decreased the level in one, then you will be able to maintain the level by utilizing the other piece of the antenna. On board the device, you can see this is just the image diagram at the front end and also rear end of the train. There are 2 antennas installed each. So you can see, as depicted by yellow dotted line, these antennas are communicating with the antennas on station on the wall. So this diagram shows what we are doing in order to further improve the quality. The first is that the onboard station is communicating simultaneously with 3 base stations. And also this applicable to the other side of the train. So there are 6 links in total maintained while it is being operated. By utilizing this, we are able to further enhance the quality. If there is a breaks or if there is any troubles with one of the onboard antenna, without any stoppage, the train can continue to be operated. And also distance. We enhance the directivity of the antennas a lot. Therefore, over several kilometers away, we are able to maintain communication. Millimeter wave, you may think that it will not be extended so far away from the station or antenna, but for maybe only for the application in the train service, if you have a directivity a lot, and then you are able to extend the distance of a communication travel very much. And I personally think that the millimeter wave is very appropriate technology for the train operation. Earlier, I explained this is the operation of the train. Therefore, you needed to have a high quality wireless communication technology that has been developed. And going forward, I'd like to talk about what will happen in the future when this train is operated commercially. What are the needs? There will be a large number of passengers on board. Of course, there will be various needs of passengers, such as I wanted to use smartphones for watching the movie, or I want to join a video conference on train. There may be such diverse needs of passengers. Then, high quality is of course needs to be maintained, and also there needs to be a wireless communication technology in order to cater to various needs of passengers. For such, as you see at the bottom, millimeter wave band 5G or beyond 5G or 6G, such large capacity wireless communication needs to be provided at the super high speed of a maglev train operation at 500 km per hour. There needs to be such establishment of the technologies. It's not an exaggeration, but I hope that as a passenger's perspective, it will be very much appreciated by passengers if we can provide such technologies to cater to their needs. The communication coverage connecting land, sea, and air. This is the topic of our session. And from 5G to beyond 5G, expansion of communication coverage connecting land, sea, and air seamlessly. That is being studied. Land, relatively speaking, technologies are established. You may think so, but even on land, there are the high-speed trains such as maglev trains, which are moving at a very high speed. There are still challenges to be overcome. This is about the standardization. If I may, I would like to briefly touch upon this. At 3GPP, the standardization efforts are underway for use cases for high-speed railway. On the other hand, as you see, the 5G at the high frequency bands like a millimeter wave, and then in that high speed, and also most of the train lines are covered with tunnels, and the use cases are yet to be developed. Even after standardization is completed, when it comes to implementation and the devices are implemented in order to provide services to the passengers on board, there are still various challenges before we can achieve those. Although there are various challenges, but on board in train cards, for example, like in the case of houses and also company offices, it's a part of the environment where people live. As you see in the train cars, most of passengers are enjoying the internet communication utilizing their smartphones. That is the current actual situation. Towards the future with the superconductive maglev train cars. We hope that we'll be able to provide almost the same environment as they enjoy in home or offices, even in the train cars. From the user's perspective, if that is realized, that will be very good for passengers. So lastly, maglev and Shinkansen, high-speed railway such as maglev and Shinkansen is an area of technology where Japan leads the rest of the world. So I hope that Japan will also lead 5G or 6G technologies for such high-speed railway in the world going forward. That is my expectation. With this, I would like to conclude. Thank you very much.
Thank you very much, Mr. Koide, for your presentation. Now let us move on. I would like to invite Chief Technology Officer of 5G Automotive Association, Dr. Maxime Flament, to present 5G Automotive Association, pioneering digital transformation in the automotive industry. Dr. Flament has provided us with a pre-recorded video of his lecture. Please watch the screen.
Hello, my name is Maxime Flament. I'm the Chief Technology Officer for the 5G Automotive Association. Thank you for the invitation to give a presentation on the current status of CV2X around the world. Connectivity for automotive is becoming pretty important, even essential in many respects. There is a whole set of automotive services that are relying on a constant connectivity. And to make connectivity in automotive a reality, it requires two major industries to understand and even trust each other. They have a very different way of working. One works on the basis of agreed standards. The other one works on the basis of competitive specs. And however, as the vehicle is sold globally, connectivity solutions must be harmonized at the global level. This is essential from an economies of scale point of view. Of course, there can be some regional flavor in terms of standards and regulations, but clearly connectivity must have a global perspective. And that's why 5GA was created, putting together the automotive and the telecommunication industries in order to address the connected mobility needs and look at this from a societal point of view. 5G aims to create a more efficient and eco-friendly and inclusive transportation ecosystem by leveraging the power of 3GPP connectivity. And the collaboration between these industries helps in deploying innovations that can improve mobility forward. The 5G Automotive Association is celebrating this month its 8th anniversary. It has become a global recognized cross-industry organization that unites most vehicle manufacturers and mobile network operators. Since its inception with 8 founding companies, the association reached now a critical mass of around 120 members, representing all parts of the V2X ecosystem and its supply chain. The 5GAA has established a set of strategic objectives to guide its work program. All activities are aligned with the services and solutions outlined in our roadmap. These initiatives are driven by digitalization of roads, of vehicles, of users, and supported by connectivity solutions and trust between various stakeholders. While we have been originally mostly addressing the connectivity and architecture aspects, 5GA has been increasingly looking at the importance of trust in the ecosystem, not only from a cybersecurity point of view, but also the trust between the actors, the trust in the markets, and the trust in the policymaker. 5GA, in a nutshell, supports 3GPP standards as a global solution for harmonization of the radio standards. We are focusing on vehicle to everything, V2X communication, commonly referred as V2X or cellular V2X, to deliver the safe and smart services. For this, we are addressing 2 complementary communication modes. The UU interface, this uses the mobile network and operates on licensed spectrum. And the PC5 interface, this is a direct communication mode enabled by the ITS spectrum, which is harmonized globally, but we will see it later, not in Japan yet. An important part of the 5GAA working strategy rotates around the road mapping exercises that we do with our members. We always update this roadmap as we go, and every 2 years, we submit it, we publish it on our website. We are preparing, as we speak, the new revision by the end of the year. The roadmaps are used to identify the topics on which the association needs to work, from a market entry barriers to standards and policy making, etc. This view of the roadmap is a simplified view. There is more detailed roadmap in the white paper on our 5G website. It depicts the complementarity of automation and connectivity. Some of the use cases on the bottom left are generally targeting to increase driver awareness about local hazards as well as pedestrians or bicycle presence. The use cases on the top right require much more cooperation between the road users and the infrastructure, and therefore it leads to additional requirements on the radio interfaces beyond what we have today on the best effort 4G mobile networks. In fact, the main attractive argument of the 5G technologies is to be able to rely on more deterministic quality of services. The road mapping helps 5G to define which topics needs to be addressed in the work program. The 5G work program focuses on the realization of the roadmap and identifies any market entry barriers for the respective use cases. For the basic use cases, we are active to speed up and scale up mobile network-based services, as well as introducing successfully LTE V2X direct communication in some of the markets, such as China, US, Korea, etc. We have spent considerable time to integrate vulnerable road users in the safety ecosystem, both using infrastructure-based detection, but also with the help of simple smartphone and interoperable apps. Additionally, we have looked at the low-hanging fruit in terms of automation with automated valet parking as well as teleoperation in confined areas. And this helps us to understand better how V2X can be used for advanced automated vehicle functions, which are mostly based today on onboard sensors and high computing units. As mentioned, CV2X stands for Our Vehicle to Everything. It is an umbrella term that may consist of different radio access technologies. We at 5GA, we promote the use of 3GPP technologies as a global agreed standards. In a nutshell, we always consider that CV2X encompasses both the direct and the mobile network communication. And we also consider that CV2X works along the earlier LTE V2X radio interfaces, which were defined up to release 15 of 3GPP. This slide shows 4 radio access technologies defined by 3GPP, 4G LTE, 5G NR for the mobile network interfaces, as well as the LTE V2X direct and NR V2X direct for the direct peer-to-peer ARC between the vehicles. We could also add other radio interfaces in this picture, such as the non-terrestrial network aspect, but we left it out for simplicity, and I will mention it later in the presentation. In China, the vehicles sold with LTE V2X direct mostly consists also with vehicles that are equipped of 5G NR and LTE, and the direct communication component with LTE V2X release 14 and 15. This is because 20 megahertz has been allocated so far in the 5.9 gigahertz ITS spectrum for the LTE V2X direct in China. Similarly, there are deployments in the US that are based on 30 megahertz that are allocated for direct communication. We are waiting for the final FCC report in order to finalize completely the access to this 5.9 gigahertz band. And another example is Korea, which has recently also allocated 20 megahertz for LTE V2X. The bottom line is that we have most regions following the same deployment pattern as China for the deployment of CV2X. This is first using LTE V2X in at least 20 megahertz of the band of the spectrum, and possibly they're looking at other options for the future, but at the moment, it's mainly focusing on LTE V2X specifically. To sum up regionally, some of the progress that has happened over the last years. In the US, the FCC, as I said, is clarifying the use of LTE V2X for short-range communication. The US DOT has also published their final national deployment plan for V2X, and several state DOTs are engaged in large-scale deployment of roadside V2X infrastructure. In Europe, many of the V2X services on the market are relying on mobile networks to deliver what they call day one services. In this respect, the initiative Data for Road Safety is a good reference for exchange of safety data between the public and private actors. The ITS spectrum for short-range communication remains technology neutral. There is still no clear industry consensus on the use of the technology. For this reason, the European Delegated Act was rejected based on the fact that it was ITS G5 driven. And we still, unfortunately, see a couple of European member states who continue to invest in Wi-Fi ITS G5 technology like Austria. This, of course, ignores the messages of 5G and the wishes of the vehicle manufacturers to shift towards 3GPP technology in the time frame of 26-27. In the meanwhile, for Europe, you have an increased attention also to cover the full road network with proper 5G coverage. That's what we call the 5G corridor project, which are funded by the European Commission. For Japan now, the IT spectrum is currently not available for V2X, except of course for the 760 megahertz. We are expecting the results of the V2X study by 2026. This will possibly lead to the allocation of 5.9 gigahertz for V2X use cases. In Korea, the government has decided to allocate 20 megahertz to LTE V2X, and the full plans on deployments are still pending as we speak. And in Korea, again, there is an additional 50 megahertz, which is reserved for future use. Finally, in China, which is the most advanced in terms of LTE V2X deployment, 20 megahertz have been allocated since 2020. There are around 30 large-scale pilots of V2X in China, and many new models have been released with V2X direct technologies. Now, almost last, I would like to talk about the role of new car assessment program, in short NCAP, to promote large-scale introduction of CV2X direct communication on vehicles. 5GA believes that this is one of the best opportunities to leverage faster adoption of direct automotive technology by the automotive industry. And in China, the China NCAP program has been released last year. It is mentioning the optional use of V2V in at least 2 of the use cases, already applicable by 2024. Even if some of the parameters will be relaxed in the first years, we believe that this would trigger mass adoption of V2X direct in the coming year. This comes in contrast with other regions like the US, where V2X has not been even mentioned yet by the mid-size US NCAP program. And in Europe, V2X is mentioned in the 2024 program, but it does not require the direct communication component. And in fact, Euro NCAP said that before considering this eventuality, they want to wait for more concrete V2X direct deployment announcements by the automakers. And they want also to have a better integration of V2X into the advanced driver assistance systems and the automated driving systems. So we really welcome the fast adoption of the new test cases involving V2V connectivity by the China NCAP. This is given that V2X direct communication deployment in China has already started for quite some time and since 2020. Unfortunately, this is not the case in the other regions. So China is definitely one step ahead. And we, of course, as 5GA, we monitor attentively the effect of what China and NCAP has on the evolution and the market uptake of V2X in China. Now, very last, I would like to talk about the importance of non-terrestrial network for the 5GA and its members. The work on NTN has started more than 2 years ago. We have published in September 2024 a technical report on the NTN automotive requirements, which then covers the opportunity of using this new connectivity. This is the full view of the released NTN use case roadmap. In a nutshell, there are no clear new use case to be expected. This is because NTN is seen as complementing the terrestrial network when the terrestrial network phase. So 3 categories have been identified for 3 phases of the adoption. One side, we have the narrowband basic services, looking at telephony, e-call, road safety, and remote services. Then wideband services, including fleet monitoring and diagnostic, as well as map and software updates. And finally, broadband services, which may be considered more as a niche or exclusive kind of use cases, because they would address at an early stage more specific kind of customers. If we translate this into technical specification for the ground terminals, meaning for the vehicles, we can split this in 2 categories. For the narrowband and wideband data rate use cases, we would stay in the frequency range below 6 gigahertz and reuse the existing terminal antennas with a rather low complexity of integration. Going to the broadband data rate category, having a larger bit rate, we need then to look at the FR2 range, even above 10 gigahertz in the KU or KA bands. And that would mean that we need to consider higher complexities for integration of the antennas and reconsidering antennas like directional phased array antennas with a form factor that is limited by 20 by 20 centimeters. With this, I would like to thank you very much for your attention and thank you for the opportunity to present our latest update on vehicle connectivity. Do not hesitate to address questions directly to me by email, and thank you again.
Dr. Maxime, ありがとうございました。続きまして、Nokia.
Thank you very much, Dr. Maxime. Now, I would like to ask Mr. Ray Tseng from Nokia, the head of ECE sales of APAC, to explain CTEC 2024 5G International Workshop.
前様、よろしくお願いいたします。
Mr. Tseng, over to you, please.
Thank you very much. My name is Ray Tseng, and I'm here to represent Nokia to give you a bit of perspective on the work we're doing in this important area. A little bit of my background. I'm a Taiwanese American and been working in Asia Pacific for close to 30 years, mostly in the telecommunications industry. In the last 5 years or so, I've been pivoting more towards the adoption of private networks in industrial use cases. So today, I'm going to tell you a little bit about one of those industries. But first, let me give you a bit of background on what Nokia has been doing in this area. So first of all, based on market research, we believe we are the largest solution provider of private wireless networks around the world. The number you see of 760, of course, continues to grow every quarter. And that's why we always put a plus, because the marketing number is never as fast as the real number. There are deployments happening that we are not yet able to publicize. But this is speeding up around the world. We do believe that private wireless networks and deployments are going to start to move faster with the maturing of not only the technology, but more importantly, of the ecosystem around each industry use cases. So why is this happening? I think the easy word to use is Industry 4.0. Unfortunately, now there are some people starting to talk about Industry 5.0. We don't even know what Industry 4.0 is yet. But let me give you a bit of perspective of what Nokia thinks this is. There are many different high-level principles why this technology is being adopted. So, of course, in the energy and particular offshore wind farm industry, it is all about sustainability. It's about, building a long-term development. Also, another big driver we're seeing for adoption of this technology is worker safety and productivity. We do find many industries, the senior engineers who really understand how everything works is, of course, getting older, and it's harder and harder to find talent to be able to follow through. And this is leading to the need to protect workers, also to make sure new generation of workers coming in can be productive as quickly as possible. Of course, you'll hear a lot of talk about enhancing productivity, enhancing efficiency. There's also a need for agility, especially in the manufacturing industry. The production line that is required for one manufacturing type may need to be changed very quickly into a different production type. Now, one of our customers told us that if you have to rewire a production line using traditional physical wiring, the rewiring of the communication network takes 1 month. So of course, if you can replace the physical wiring with wireless communication, it saves you 1 month, right? And imagine how many times you will do that in the life cycle of a factory. Ultimately, what all of this technology does for management, for the CXOs that have to make decision, is better decision, so that you get the real-time information as quickly as possible. Now, one thing I will talk about at the very bottom here is Nokia's focus is real production-grade deployment. We, of course, still do a lot of proof of concept, but we have moved past production globally about 4 or 5 years ago. And all the 700 sites I talked about, majority of them are production scale. We are no longer only talking about proof of concept. And to do so requires us to focus on industries that requires this technology right now. Not about the dreams that we will talk about. Of course, there are many new use cases coming, but for this to become a real business and to be a sustainable business requires us to serve industries that have a real requirement. And what we see mostly is in the heavy industry sectors. So I am responsible for the Nokia enterprise business across Asia Pacific. And the one good example of heavy industry is our most successful industry is in the mining industry. And a lot of that, of course, is in Australia. The next industry we do see will start to have a lot of requirement is going to be energy industry, like wind farms, offshore oil rigs, and also logistics and transportation. So seaport, airports, rail lines like the wonderful magnet technology that is coming from JR. Those are the type of, and what we call asset-heavy industries that needs the technology now. Now, if I take the wind farm technology as an industry sector, even a subsector within the energy industry, then we have a lot of cases where we have real deployments and we clearly understand the customer challenge. So the key is to provide at the starting point a reliable communication platform. This is the foundation of all private wireless. It's not a very sexy use case, it's not a new dream use case, but it is a required use case, right? And why does this happen first in offshore and wind farm type locations? Because there's no coverage. And that's why we need a private wireless network to enable that basic use case. Of course, once you have that basic use case, you can start to connect the offshore requirements to the onshore requirements. You can start to overlay lots of new use cases like IoT, like sensing technology, again, to give the management team much better decision making. There's another interesting dynamic too in most of these type of projects is that there's a requirement even during construction phase. When nothing is there, you still need to communicate because you need to enable the workers that are building these sites to communicate. So there's a requirement pre-production. And then once you go into production and it becomes more of a maintenance platform, then you want that same investment to persist. And this is very important learning as you go into real operational cases. So I'm not a technical person, but fundamentally this chart is showing you that a real wind farm will have the wind farm, it will have the offshore platform, it will of course need to connect to the power grid on land. And what we need to build first is the underlying communications platform that is required for any use case. And of course, there will be some physical infrastructure as well as some wireless infrastructure. And we are one of the few companies in the world that understand end-to-end all the physical requirements all the way to the wireless requirements, right? We have the connectivity infrastructure, we have the MPLS IP backbone infrastructure, of course also the 5G and in the future 6G infrastructure to come. Now, Nokia has been in this business for many years, and I would say that the focus in the initial stage is about the communication platform, but the focus in recent couple of years is now to enable the use cases and applications running on top. So what you'll see is that Nokia is building a very robust ecosystem of applications that runs on top of the foundational platform. And this is important because I think some of the other speakers talk about the big macro challenge we have is trying to bridge industry requirement and the communication framework. So the communication industry comes from standardization, 3GPP, as the last speaker spoke about. But the industry requirements does not really care. Industry does not care about what G we're deploying. It does not care about 3G or Wi-Fi or 4G or 5G. Industry requirements care about what's the business benefit we're going to get, right? So what Nokia has been building and what we understood from all of our 700 plus customers is that what we need to do is give more value to the foundational investment that any company is making on these beyond 5G platforms. So the way that Nokia is doing this is we have an ecosystem of solutions that we're putting together. And you'll see that the light blue, the blue areas are all solutions that Nokia is building ourselves. But this is an ecosystem, this is a platform. This means we are also inviting a lot of partners to come into this ecosystem. And one of the challenges I would like to throw out today to the Japan industry is if anybody wants to participate in our ecosystem, please do let us know, do contact us. We will help you to include you into our design framework. And what we want to do is present the benefit of our joint solution together as a partnership back to the end customers. This is very, very important because most end customers, when they look to deploy these type of solution, have a hard time understanding who do I need to work with. Do I work with a telecom operator? Do I work with a vendor like Nokia? Do I work with specific little application vendors? And it is too difficult in early stage. Once we're able to work together as an ecosystem and present the solution benefit to the end customer, adoption speeds up and it becomes much easier to help industries leverage this technology. One example I want to showcase is we're launching this year a video optimization technology. This is a foundational layer. What we see is that even with 5G, the amount of video use cases is increasing dramatically. This is one of the easiest ways to sell the benefit of these new next generation technology. But the problem is, even with 5G, a 4K or 8K video stream is huge. So if you want to install many, many cameras for many use cases, or camera on a drone, or camera on a moving vehicle, one of the foundational challenges we have is you cannot transmit so much video information in real time. So we have invented, this is done through our Nokia next generation R&D department. We invented some video optimization technology that allows any video use case to compress by up to 95%. So this means for an 8K 360 video camera stream of 140 meg, we can transmit for a focus area of less than 5 meg. Right? And by doing so, this will allow us to unleash more video use cases, again, that will take advantage of the underlying platform. I see that I'm running out of time, so I'm going to just move very forward quickly, just to help you understand that we are deploying these technologies in production environments, and this is what is really needed to move the industry forward, is to move beyond POC and putting it into real use cases. This is a case by Net Nordic, is one of our great SI partners in UK, and Equinor is the wind farm that they're actually a renewable energy company, and they're deploying this solution in their wind farms for their daily operation and gaining tremendous value out of this. Another case here is a very similar case with Petrobras, which is a Brazilian, a Latin American oil company, and they're deploying these solutions in their offshore oil rigs. And in this particular case, the private spectrum is not available, so it's done through a partnership with Telefonica. So I will end with a short link that, if there's any interest, please take a look from an energy perspective. But hope you can see that we are participating in all the major asset industries, all the industries that require this technology today, and look forward to connecting with you. Thank you very much for your time.
Tseng様、ありがとうございました。
Thank you very much.
続きまして、
The next
KDDI
speaker is KDDI Smart Drone Inc. CTO, Mr. Hiroshi Sugita. The title is The Changing Drone Industry with Mobile Communication and the Deployment of Smart Drones. Mr. Sugita, over to you. Thank you very much. I would like to explain the changing drone industry with mobile communication and what KDDI is doing with regards to drones. This is a self-introduction slide. KDDI is the third company that I'm working for. I worked for a large precision company and then a large electronics company and now at KDDI. So I have covered, for example, satellite systems and land systems, and now drones. So I have done almost everything outside of the ocean technology. And in terms of drones, I have been working with the government, Messe and MLET workshops. So I am in a position to know about what is happening in terms of the government systems and how we are building the infrastructure around drones going forward. So I give a lot of presentations on drones, but today the theme is communications. But before talking about communication, I would like to talk about drones. So drones started from a consumer-based technology, but now it is shifting to more enterprise use. And it started by a agrochemical or dispersion, but now drones are being used more for measurement. And now more and more infrastructure companies are using drone technology beyond POC and for actual commercial use. And when we talk about drones, they are a flying robot. And given Japan's aging and declining population, drones are an effective tool for labor-saving technology where people do not have to be present. Now, like automated driving on the ground, for drones, there are different levels in the operation. There are 4 levels. One is whether the area is manned or unmanned, and the horizontal is whether it is manual operation or autonomous operation. And when we talk about manned area, this is more about third party, meaning whether drones will be flying over populated areas. Factories or rivers are more managed areas. And so, for example, autonomous flight without pilots being present on the ground, the so-called beyond visual line of sight flight is possible for unpopulated areas. And for level 4, autonomous flight with populated areas or manned areas, this requires more social acceptance. And now this is still in the demonstration phase. And for drones, communication is a must. If it is beyond the line of sight, communication is absolutely necessary because you will not be able to see anything without. And so mobile communication is going to be essential. So there are various use cases. For example, drone logistics for remote islands or ocean mountainous areas that is often talked about on the news. But for example, for inspection, if there are structures that inhibit the line of sight, then you need to have another person to be able to provide line of sight. But this will no longer be necessary with a level 3 or level 4 flight. And in the future, global level or operation will be possible without having people present. Remote operation from far away, it will become possible. And there are basically 3 types of uses that I want to talk about today. One is this remote flight, and the second is utilization of data. So AI analysis, 3D model analysis is what is being planned. And with regards to the drone operation, I'm sure that you think that the MLET is controlling this quite strictly. But going forward, with the huge number of drones in operations, the private sector will be taking over the management, and ensuring safety is going to be more important going forward. So as KDDI, the drone industry is undergoing significant change in terms of technology, and you also need expert personnel. So from 2022, KDDI Smart Drone was established as a startup. In terms of the main business operations, there are 3. I am a part of the platform business. So on the left-hand side, mobile communication, cloud, and application development is what I am working on. But there are other business lines. For example, by application solution development, solutions for each industry. And also you need education. And the MLET has developed a certification system for drone operators. So we have developed the KDDI Smart Drone Academy to provide the training for drone operation. So I mentioned that I am in the smart drone platform business, and we work with various partners in connecting to mobile communication and developing applications for end users. And going forward, we will be connecting to the national government system as a one-stop provider. As was presented by Nokia earlier, even if the platform exists, for the service to be provided to the customers, there needs to be the linkage with the customer system. So rail business or road business will be working with various partners so that we can further penetrate in the market. Let me briefly talk about the remote operation service. Basically, we use the cellular communication for remote operation. SIM slots are a standard equipment for drones recently. So, like smartphones, drones are connected to the cellular network. In the past, the drones had direct communication with the operator, but going forward, the drones will be operated via the cellular network via base stations. And the drones did not have a standard OS. So we were working with various manufacturers, the main Japanese and global manufacturers of drones, and we are able to connect seamlessly. I think a video will make a much more clear image. And so this is from Mie Prefecture, Shima City. There is the cellular module on the drone, and we are able to fly this remotely. And so this can be viewed from Tokyo, for example. And currently, this is one operator managing one drone, but we are working with the government project for a one-to-many operation, which is in a practical phase. Thus far, for one drone, there used to be 4 or 5 people who are operating or helping to operate. But going forward, it will be in the reverse direction, one person operating multiple drones for further labor saving. In terms of the frequency, provision, we have been providing this map. And we already have the terrestrial network that we have been developing as KDDI, and this will be something that will be added to that. And the point is that a few base stations will be in play, and there could be interference. And so even though there are antennas, interference could be a challenge. And so we will be gathering more and more data for more advanced data connectivity. And the drones are evolving as well. And we have recently partnered with Skydio with a 5G module that is equipped on a standard basis. And there is a more autonomous driving like technology to avoid collision. So even if you operate rather roughly, you can avoid collision and have a very smooth operation. And these are docked drones. These are like boxes that are connecting to the mobile network and other networks. So we would like to develop a structure where from Tokyo you can monitor all the facilities in Japan. So, for example, theft prevention monitoring is being utilized, and also on the construction areas and plants where you're not able to provide security personnel, drones will be used for monitoring. In terms of logistics, there are still many challenges, and this problem is not just with drones. There is the physical internet, and for the Japan is facing a structural issue where the logistics network cannot be maintained throughout all the remote parts of Japan. And for KDDI, we have Lawson as a partner, and we're also using various public facilities like schools or city halls, and working with the governments to provide drone distribution. In terms of the data analysis, it was a challenge for drones to move away from the POC stage, but now we are in a stage of providing AI service with drones to user companies. And the important thing is not just to fly the drones and gather the data, but to have drone and AI utilization as a premises to improve the existing workflow. If you try to maintain the existing workflow and add AI and drones, it doesn't really make much of a difference. So business transformation, workflow transformation must come hand in hand with the usage of AI and drones. There are going to be more and more use cases going forward. And this is a video to show you what is possible in terms of the bridge inspection. Drone is taking this image and it is creating the 3D image. In terms of 3D data usage, there are various discussions on how this can be utilized, but technologically, this is the resolution that is available. So the skills of the existing engineers, how that can be further analyzed with data. And going forward, the constructions will have 3D imagery from the first place using CAD. So that will also be available together with the drone data for further analysis. Now, as a mobile communication with drones, 4G was used thus far, but together with MIC, we are now promoting 5G based operation for drones as well. But high frequency is difficult for wide areas. So for factories or densely areas with dense traffic, we will use a high frequency. And also for mountainous areas, cellular coverage is sometimes difficult. So we will utilize NTN like HAPS or low orbit so that we can maintain the entire coverage. And KDDI has been working with Starlink. And in terms of the drone technology, NTN has an important coverage. And we do need to utilize satellite to cover for the shortfall. And where we were not able to provide sufficient coverage, Starlink will be able to fill that gap. And so this is something that we will be working on as well. So what will be possible with 5G? Thus far, our drone industry first took the video with the drones, and then this was downloaded onto the PC and then analyzed in the office later. But with the 5G network, you can do remote operation as well as data analysis on a real-time basis. Now, for infrastructure, the government is working on the system for low altitude operation. And in terms of the space, there are drones, but also helicopters and other aerial vehicles that are operated or piloted, which we need to avoid collision with. And of course, we need to make sure that there is information linkage with people in the field. So we are working on both of this. So in case of drones, there are many existing rules which inhibit the entrance of startups. So what we are trying to do is that you just provide the app, and if you have a pilot, we need to make it easy to be able to operate the drone safely. So we would like to work with the various players so that drones can be utilized in various industries. And KDDI Group alone will not be able to provide all of these operations. And that is why from last year, we have been working with Japan Airlines on the operation for low altitude operation so that drones can be a part of our basic infrastructure. Various drone ports will be deployed throughout Japan, and this will be used not just during normal times, but also during natural disasters. In January, when the Noto earthquake happened, we also were deployed on the ground. And also, in order to survey the situation after the earthquake, drones were used. And we were able to see the situation after the heavy rains that happened just a few weeks ago. And we were able to monitor the difference with the drones. We have an imagery, so we'd like to show you briefly. So this is the footage. And from Tokyo office, we are remotely monitoring the situation every day. There are a lot of information, but most of the information is analog, and it is difficult to discern what is happening on the ground. But this is a regular flight drone. So we are able to see exactly what is happening today without having people present. This remote operation and one-to-many operation is going to be developed going forward. And we would like to work with the members of the industry to further implement this in the society. And in the future, we would like to work not just in Japan, but also with overseas partners. So beyond Skydio or partnership, we are looking into expansion in East Asia and Southeast Asia. So once we have built the infrastructure, we would like to work with global partners. I would like to thank you for this opportunity.
Thank you very much, Mr. Sugita. Next, I would like to call upon Dr. Ryuji Wakikawa, Research Institute of Advanced Technology, Vice President of Head of Research Institute of Advanced Technology of SoftBank Corporation, who will speak about connecting with space. Hello, everyone. My name is Wakikawa of SoftBank. Thank you very much for inviting me today. And connecting with the space, today I will talk about the space, particularly focusing on hubs. Connecting dreams. I think that day before yesterday, Booster was captured by SpaceX, and I thought that that looked like an AI created image. But as you saw in the case, there has been a lot of advancement in space technology. So today, I would like to touch upon what we are doing in Japan as well. I am heading the research institute within SoftBank since April 2024. Other than hubs that I will speak about today, I have been engaged in various activities in various fields, out of which, beyond 5G and 6G, there are 12 challenges in these areas. Since 2020 onward, we are conducting these activities towards 6G. If you search on the web, you will be able to see more details on these. And the world view of 6G, I believe the other speakers or people in the audience have explained industrial application or observation of the earth and society. This away from the smartphone of the consumer's network is going to be utilized. So this is the worldview we are creating. SoftBank, what about what we are doing in the space? On the ground, there is a ground station on the left and a non-terrestrial network or NTN. Not only hubs, but this includes the LEO and GEO. So we are also conducting various activities in these areas. As you see, LEO, the Starlink, KDDI, Starlink business is also provided by us, and low altitude satellite, and also OneWeb, Eutelsat OneF 2024, we are starting to provide services. So today I would like to focus on hubs. I have been speaking about hubs at various places. You may think that I am repeating, but I have brought with me new topics to share with you. And since 2018 or so, SoftBank has been working on these hubs. In the stratosphere, stations will be lifted up in the stratosphere. Stratosphere is unprecedented or not proceeded with by the human beings. There is no industrial activities. We thought that if we can bring up the station there in the stratosphere, we thought that we could expand the coverage. And this is the Sand Glider made by SoftBank as a prototype. So what were the characteristics of hubs? We still have gravity, not completely in the cosmic space. So utilizing solar power to generate power, and the onboard battery will store the power in order to continue flying. And then pivoting with optional coordinates, so you are able to have a fixed point observation, and you will be able to create a wide coverage with about a diameter of 200 kilometers. So what is different from the low altitude LEO satellites and Starlink as well, that they are conducting various activities in the LEO. So there are differences. Utilizing the characteristics, a hybrid network is going to be established. What is the difference between LEO and hubs? Distance. For hubs, 20 kilometers above the ground, therefore very close to us, therefore low latency communication can be realized. When it comes to LEO, it's in the space, cosmic space, therefore distance is long, therefore there may be some latency, and also mobility and large scale, the antenna will be necessary. Needs to be a line of sight above. Hubs, it's only 20 kilometers away from the ground, so you will have the line of sight. And with the communication, you may think that this is possible. On the mobile phone networks, ground stations in local areas, there is a very high still tower in order to cover 20 kilometers. So it's only converting to the vertical light. And the line of sight, there is no obstacles above us in the sky. Therefore, the environment for communication is very favorable. For us, LEO is more advanced, but we think that perhaps we will continue our R&D in the HAPS area in order to commercialize it, and we would like to continue to provide integrated infrastructure. SoftBank has been engaged in the HAPS development many years ago. Actually, there are people, teams, NICT. Since 2000 or so, 3G stations were utilized in order to launch HAPS by NICT, but due to various reasons, the project was suspended and SoftBank succeeded, and we brought in activities, standardization of the frequency bands, expanding, and the HAPS Alliance was established. Creating the industry alliance. What is most difficult about HAPS is a regulation or rules, airframe or ICAO operation rules. The state members are participating in such forums, so SoftBank does not have a voice. Therefore, creating the alliance and the industry group and 82 companies have participated. And SoftBank and Japan have made a great achievement for this frequency. And HAPS, it's a mobile business. Therefore, you needed to have the mobile WRC ITU. Utilizing the standardization process as the frequency was acquired from HAPS from about 1.9 and to 1.1 gigahertz. These two were the only available bands. Other than that, the regulation may have to be violated, and 700, 1.7, 1.9, 2.1, and 2.6 gigahertz were offered, and at WRC 23 discussed, and as a result, as you see, so these were allowed to be used in countries. So we made the rules, and going forward, the technology used, and then we will be able to apply this. So feeder link in a backhaul, the wireless communication is applied for this. Since many years ago, these have been defined as 6.5, the 38 and 27, 21 and 26 and 38 gigahertz newly added bands. So there are feeder links. Preparations are underway steadily for wireless radio and wireless communications. We have been able to establish certain rules. 3GPP as well. As regards to the HAPS, there have been a study being conducted. HIBIS is the name, HIBS. HAPS as an IMT-based station. HIBS Release 17, the part of the concept has been adopted. Like this, standardization is ongoing. What is most important is how to lift up the station. We have a larger scale hubs. We tried to develop actual thing. In 2020, the test flight was conducted to demonstrate the technology. The characteristics of airframe is very different from others. The wingspan is 80 meters long, therefore it's almost the same as the jumbo jet. So very large airframe payload. So how heavy it can be when it comes to something to be lifted in the air. So we needed to have this large size for hubs. This is the mobile business. So from above, and then the radio needs to be airborne for a long time, and also the large hubs was necessary. So we are creating the airframe. SoftBank doesn't want to be a manufacturer of airframe. We are a provider of services. Without having actual airframe, we are developing, but in the future, we would like to combine various types of models. And the hubs, what is most important is the powertrain. How long are you able to stay above in the sky? And the power generated by solar will be stored in the batteries during the nighttime, utilizing the battery. And then, but 1.7 times difference, 300 in January and 500 in July. So there is a difference in the insolation. It will depend on the latitude, and because of the angle of the sunlight, the power generation will be different. Close to the equator, the insolation will be large, therefore the power generated will be very large, but there will be a big difference between the 1.8 times difference when it comes to the latitude at 30 degrees north latitude. So the why the HAPS is being developed as such because of a difference in insolation and the power generated, and the monitoring for the disaster, and we are focusing on the communication. Therefore, over all around the year, we would like to create the area coverage. But when it comes to the spot flight, is it possible? Yes, we can. For example, during the winter, we are able to fly on a spot basis. But for us as a carrier, we would like to fly this HAPS station all around the year. So it is said that limited, but at time of disaster and monitoring, we are able to commercialize this technology right now. But we are focusing on the communication area. We are now putting on focus on other areas, but this is what we are currently seeing. And in 3 years from development of airframe, we have succeeded in reaching the stratosphere. This is meaningful. We tried flying in the stratosphere once again. In August 2024 in New Mexico, we did it. Actually, there was a customer utilizing our airframe. That is a DoD of the United States. Department of Defense utilized our airframe, utilizing their payload. They didn't tell us what they used as a payload. They loaded various payloads on the airframe. We conducted demonstration projects together with a company in the United States. So Japan-US cooperation is being made in this kind of activity. I am not able to show you the video. You will be able to see it in the YouTube and so forth. And the remainder towards 2027, we are continuing on the R&D. This is new topics. 5G expanding our dreams. So when it comes to the ground communication, that is, we believe, very important. For that, we started new endeavors, initiatives, as I said, feeder link and service link, utilizing the radio waves, frequency bands in order to create this HAPS. But feeder link, you need to have various gateways, and depending on the condition of the atmosphere, it may hamper the communications. So we thought that maybe satellites can be utilized, or we can build a mesh in the atmosphere and the redundancy can be enhanced. So utilizing this kind of a concept, the inter-HAPS communication. So E-band, frequency band was used in the past, but we are going to utilize the optical wireless communication beyond radio. So optical wireless communication is something that we are working on. In other countries, the constellation, the optical wireless communication is used. The SpaceX is also utilizing this. In the space application, it is expanding rapidly, and optical wireless communication is not affected by the fluctuation in the atmosphere. It is easy to use in the space. Together with NICT, this kind of optical wireless communication technology needs to be commercialized for the LEO satellites and inter-HAPS and the ground. We are going to apply this optical wireless communication in order to create a large-scale space infrastructure. And towards 2026, we are developing these underlying technologies are being developed together with the NICT as well as the national project as well. We are working on this now. So at the SoftBank, we are doing with on the LEO and the HAPS. So we are developing airframe for this, but not only hardware, but as a service provider, standardization of frequencies and development of underlying technologies, and beyond them, LEO and HAPS to be integrated together as an infrastructure where the space network utilizing optical communication technology will be utilized. Utilizing these 5G and industrial application, we will be able to create emerging needs for that. With this, I'd like to conclude. Thank you very much.
Thank you, Mr. Wakikawa, for your presentation. With this, I would like to conclude lectures from 5 speakers on latest trends in industry use of 5G communications, spreading dreams on land, sea, sky, and space. We would now like to take a short break. We will start again at 11:50. Please come back by then.
お待たせいたしました。
Thank you very much for waiting. We would now like to start the panel discussion. The title of the panel discussion is 5G Communication Spreading Dreams on Land, Sea, Sky, and Space. The panel discussion will be moderated by Ms. Rika Oyama, a CEO of Onboard Inc., and as a commentator, a representative of XG Mobile Promotion Forum, professor of the University of Tokyo, Professor Morikawa will be serving as a commentator. Now, I would like to hand over to our moderator, Ms. Oyama. Hello, everyone. I am Rika Oyama. I'll be serving as a moderator of this panel discussion. I would first of all introduce our panelists. Starting from left of me, Koide-san from Central Japan Railway Company. Hello, everyone. And we have from NTT Docomo, Mr. Shibayama. From Nokia, we have Rei-san. From KDDI Smart Drone, Sugita-san. And from SoftBank Corp, Wakikawa-san. And commentator, Professor Morikawa. Thank you very much. Now, today, when I heard about this, I was surprised. We are to talk about land, sea, sky, and space, and SoftBank. I used to talk about outer space, so we are covering a very wide topic. So by listening to the title, it seems as though that we are trying to cover different areas. But since this is a panel discussion, I hope that it will become a kind of discussion session. So Professor Morikawa, as well as the panelists, I do hope that if there is anything that you would like to say, or is there anything you would like to ask, or you want to ask a question, please raise your hand. I would very much appreciate that. And earlier, we did listen to the panelists' lectures. However, there's one person who is joining the panel discussion only. I would like to ask Shibayama-san from NTT Docomo to introduce himself. My name is Shibayama. I'm from NTT Docomo. 5G lectures were provided, but 5G CTO was supposed to make a lecture, but since he was not able to make him available, I am joining the panel discussion representing him. So I thank you very much for giving me this opportunity. So at NTT Docomo, connected car, the future autonomous car is what we are focusing on, and we doing R&D activities on how we can realize the communications in autonomous driving. Personally, I was in charge of satellite ground base station development as well as wireless technology development. Thank you very much for this opportunity. Shibayama-san, thank you very much. So we would like to start the panel discussion, but I work for a company called Onboard. So people who work for companies and people who have stopped working for companies, together with those, we have a very diverse team of members to support various research activities in and outside of Japan. And we call these retired personnel legends, and we found out that they want to know more about commercialization of the technology and this dream technology. So that is what I would like to ask each one of you. So as the first speaker, we did hear about this during the lectures, but Nokia's Ray-san talked about made an appeal to the Japanese companies. So I have a question for you. What do you think about the Japanese market from a global perspective? Can you explain what you think about the Japanese market? You talked about marine, offshore, but if you cover other areas as well, and tell us what you think about Japanese market, please.
Thank you very much for the question. So I think having coming to Japan market for about 30 years doing various telecommunications type of business, I've always appreciated that Japan is a very quality focus and a very careful market. And I think when it comes to market adoption, that of course it has a lot of value because it makes sure the technology is well understood before going into production. But there's also a downside to being so careful, is that adoption can be quite slow. And I think if Japan wants to maintain kind of global leadership, there is a need to strive for production deployments a little bit faster. Now, I will say that I'm also Taiwanese. I'm very aware of the need for careful coordination. So I'm not saying to move as fast as, say, startup companies in America, where maybe it's a little bit crazy too fast. But I think there is a nice fine balance to be a little bit more courageous in deploying the basic use cases, leveraging the same foundational investment, knowing that the newer use cases may not be ready today. So start with something basic, even if the investment ROI is not great. Think about the 3 to 5 year ROI when you can add more use cases on top of the same initial investment. So that would be my view of the broader market across pretty much all the industries, but specific for the Japan market. One last thing I will say is, as I mentioned in my talk, it is very important to pick the right industry verticals. Sometimes companies try to serve too many industry verticals at the same time, and that is not productive. You end up doing a lot of POCs with very little actual return. So that's my input. Thank you.
ありがとうございます。勇気を持ってチャ
Thank
レン
you
ジ
very much. So be courageous. That was the message. And I have heard this from Professor Morikawa as well. So I like to ask a question to you, Ray, as well. So you are looking across the enterprise customers. And I'd like to ask you, which sector has the biggest possibility and which sector has the lowest potential? How do you view this?
Yeah, so I would say that eventually this technology might be adopted by almost all the enterprise industry. However, as you said, Professor, there is a timing element to which one happens first. So our learning is the first one that happened first, already happened, is the mining industry. So we've been very successful in the mining industry. We deployed in Australia over 10 years ago, this same technology we're talking about today. So I would say there is already a lighthouse to point us the way. What we're seeing, the next one coming that is happening now, is the energy sector. Very similar dynamic to the mining, but maybe a little bit more diverse in the use case. And then very quickly after, also happening now, is the transportation and logistics industry. I would say though, the long term, probably the bigger industry is manufacturing. But manufacturing is very fragmented. one type of manufacturing is very different from another type of manufacturing. So I think that will take a little bit longer time, but eventually that may be the biggest one. Thank you.
はい。レイさんありがとうございま
Thank
し
you very
た。
much for the response, right? So next, I would like to turn to the other speakers, starting with Wakikawa-san. So you talked about amazing platform in the sky. And from 2024, there is like a vertical evolution of the technology. But what kind of business will actually be realized as a result of this? And do you also plan for a global expansion? Those are my two questions. So when it comes to HAPS, actually, Japan is in a difficult location geographically. And looking at the stratosphere, there is a strong wind factor. So battery and solar panel technology needs to be further enhanced to fly HAPS 24/7. So maybe the southern part of Okinawa may have potential, but in terms of building the infrastructure in Japan, from a 24/7 perspective, it is very challenging. But Japan has a lot of natural disasters, so in terms of a hotspot type usage, there is more potential for HAPS. Now, looking at our company's base station business, countries around the equator has more potential. And these are areas with rather low penetration of the internet. So maybe there is more potential there. SoftBank used to be tying up with Google's Loon project. And they were promoting internet connectivity to the Africa region. And in terms of HAPS frequency, we need to always consider how this can be deployed on a global basis. But from the commercial perspective, HAPS is finally getting traction, and the government and consumers are becoming more interested. So we need to develop services using HAPS. We need to generate revenue through HAPS. So now there are satellites and HAPS and various other technology, and how we can commercialize this is a big challenge for us going forward. But this is a chicken and egg issue. Without technology, there is no business. Without business, there is no technology. So in that sense, running this cycle is where we are struggling at the moment. At the same time, this is not a business that we can do on a standalone basis. We have to work with the alliance partners. We have developed the HAPS Alliance, which is most domestic and international, and we would like to develop the technology through the alliance.
Thank you very much. In that sense, going forward, we needed to create an alliance and networking among peers. With what kind of sectors or industrial players would you like to have in your group, contents or services? As regards to connectivity, wherever areas can be existent. Therefore, in connectivity, we do not see a lot of value. Out of a range and a connected service will be provided. Who will become happy? As Ray mentioned, mining, the ground station, we are operating company. We don't want to have an infrastructure for areas where there are no people at the construction work site. We do not have people there. And then how infrastructure can be established. And then HAPS or in mining in deep in the mountains. And infrastructure development is quite hard work, and a fiber needs to be installed to have the power supply, and it will be costly. Then HAPS can be applied maybe, and in Japan we are prone to have a lot of disasters, and for us the ground stations are affected by flood, and the fiber may be cut off, then cutting off the communication. So how much you pay for that, and connectivity, it can be realized, but the HAPS will not be affected by what is happening on the ground. So connectivity there will be very valuable. So in terms of connectivity or communication, hubs itself does not have a value. What can be done utilizing hubs will be something that will be really valuable. So in that sense, we needed to have discussion with various parties in various sectors. Professor Morikawa, if I may, sorry. Again, me, Dr. Wakikawa, when I discussed with you the other day, I was impressed. You are heading the research institute. All the projects, you are asking people to come up with a business plan. So I suppose that you have the business plan for hubs. When you create a business plan, customers are considered to be operator or any other people involved as other parties than operator for hubs? What are the assumed customers? It's quite difficult to answer. Well, of course, the operator is one of the potential customers, and connectivity can be realized in various ways. There will be various operators with hubs. We don't want to have many people as operator. Power company in the US, and one single set of data can be shared, and then operator can be our customer as well. On the other hand, at the hotspot of disasters, and government or public sector can be our customer. And with our expectation for hubs, when having the devices in place and the connectivity can be created, and then the camera installed, and you are able to use it for surveillance or monitoring, and the payload can be variable for different purposes. So for each different application, we can consider different kinds of customers. Who is going to pay first? We have the expectation to the first payer, government. When we conduct on this large-scale hubs project, it's very difficult for us only in the private sector to do. As operator, of course, we will pursue connectivity, but we needed to tie up with the government. If that is possible, that will be favorable. And the hubs technology, not only by us, but Docomo as well, and KDDI has joined the hubs alliance as well. So in Japan, these technologies have been developed by Japanese players as a whole. So maybe not in Japan, but for us, hubs technology, we hope that we can commercialize various applications utilizing hubs. Thank you very much. Next, Sugita-san, I'd like to ask you regarding your business model utilizing drones or UAVs. Thank you for your presentation. What kind of a market? In which market segment do you see the most potential, or what segment are you going to focus most? And you talked about inspection and monitoring, large corporations or small companies in Japan. Could you please consider them all when you think about the focus areas? Yes, right. After we started our business based on drones, and I'm speaking with members of our team, it's like a school excursion for students. Well, infrastructure, like including the construction sites and also substations and equipment for train and expressways. So whatever we see as a visible infrastructure, well, I think that now they are working with a very significant shortage of workforce. So far, senior experienced people, skilled workers have been maintaining the infrastructure. Actually, we are reaching the limit of relying on those people because of the shortage of labor force. And younger people utilizing the smartphones and communication network, they do not opt for working at the places where there are no such communication or connectivity services. We needed to make such a work area smart and cool to young people so that we can attract the younger generation as well. That is the common issue we face. And particularly construction work sites as well as the structures as infrastructure, these are indispensable segments for the market. So I believe that our technology can be introduced widely in these areas. And the logistics area, we have structural issues, and therefore it will take some more time to introduce it. And at KDDI, And we have an operating company established within the group. And when it comes to communication devices, which were mainly used for network building, and information systems department was working with companies. Now we are working on the real sites, like persons responsible for equipment, facilities, and those who are working in person with other people. So that is the fundamental point or change that we have seen. In that sense, the drone is one of the tools we use in order to find solutions to the issues faced by customers on site. And drones and smartphones and network cameras compound solutions are needed to be applied to find a solution. That is the kind of phase we are in now.
Thank you very much. So on the ground, there are many issues like somebody is not present. So therefore, I think there is a lot of potential for drones. Just one more point. Is it going to be the big companies that are going to play the main role? I was involved in agriculture in the past, so maybe small farmers can also be, is there potential for them to use drones? In terms of agriculture, already we have agrochemical sprayers, small farmers already using drones for spraying agriculture. So I believe that there is a penetration of drones in certain regions. And the challenge that I face when I serving as a committee member of the government, it seems as though that it is not easy to approach. So therefore, and that is, I believe, is the reason why we don't see increase in the number of startups. But startups, the key is for startups to be able to start by utilizing cloud. There are and since that if that cannot be done, that could become barriers to start up a business. So we are working together with the government to work on a navigation and management system. So if we come up with applications and the application complies with regulations and so on, smartphones, we have to make it so simple, such as simple as development of applications for our smartphones. We have to make it easy for people to start the business, and another key is how we can collaborate with the local regions. Professor Morikawa. KDDI smart drones in 10 years' time, what is going to be the revenue size and what is going to be the business segment of the company 10 years later or 15 years later? So navigation management system is going to be the main business, and utilizing that system, third party would customize the system. Is that the kind of a vision that you have for your company? So since I am the executive management of the company, Professor Morikawa said 10 years, but actually we are thinking about 25 years later. So from beyond next fiscal year, we are going to start the operations nationwide. So what about the business the growth? I think there are various options. Globalization or expansion to international markets is one. But when I start working on this, we are facing different barriers unrelated to drones. So are we really focused just on drones is something that we need to think about. So since we are the one who are directly facing the challenges of the end users, so we are serious to think about what our business scope is going to look like in the future. Thank you very much. Shibayama-san from Docomo. I would like to ask you a question. 5G AA. I see that there are various working groups in 5G AA. And inclusive of Docomo, how can Japanese companies be successful in the working groups? And what is the focus of the Japanese companies? The 5G AA is working globally, and the industries that are part of 5G AA are automobile industries, cellular, as well as communication or manufacturing companies of telecom devices and so on. And each industry has its own goals and what they are looking for. So, and as was mentioned in the previous lecture, so the goal is the same, to be able to drive cars safely. And safety and sense of security, which includes protection of bicycles as well as pedestrians, and also to get the data such as the frozen roads as well as something falling objects. Such kind of data could be communicated to the cars driving behind you. So that is something that we are working on. And this was also mentioned during one of the lectures, but since this is about communication, as we try to globalize, there's a need to be able to communicate using the same spectrum. So talking about automobile communication, there are two. One is using cellular, and the other is the direct communication between vehicles, as well as communication between between devices on the roads and the vehicles. And there is no common spectrum. So 5.9 gigahertz is now being considered to be used as a common spectrum, and we are working on that. And in the case of Japan, MIC is working on this. And in the study groups of MIC, there is an ongoing discussion to make sure 5.9 gigahertz can be used for this purpose. Morikawa-san, do you have anything to add?
Thank you very much. I'd like to ask about connected. Ray-san, Wakikawa-san, how do you see this? And then we'd like to ask Shibayama-san to comment once again. So since this is a discussion, Ray-san, can you comment on this topic as well? Connected car industry. What are your views regarding connected cars?
Yeah, so I think that connected car will probably take a bit of time. So it won't be the fastest industry, but certainly is a necessary requirement going forward. So it's one of those things that it will happen no matter what. It's just a matter of timing, right? We are already involved in deploying in test tracks in Japan. So we are also involved in that industry. But again, from our perspective, providing the connectivity layer, we're a support player, not the main player.
Wakikawa-san, please. Well, from the connected perspective, there are two things that I have in mind. One is more of an entertainment user experience. So being able to access, for example, the broadcasting, and 5G is already deployed in many cars today. And there's PC5, that's more for safety. And this has a lot of regulation, and it's a heavier area than entertainment when we consider safety. And in today's presentation, the 5.9 gigahertz being the global standard, Japan is still playing a very small role. And how we can accelerate this process, or what should Japan do at this time and age? That's something I'm very much interested in learning about. Shibayama-san, can you comment as well? Thank you. So Ray-san said that it's probably going to take some time to realize connected cars. And I do agree, because having the same global standard and penetrating that standard is going to take time. But the Ministry of Internal Affairs and Communications, MIC, it has been promoting various POCs and demonstrations. And with the government taking a leadership role, we would like to accelerate this in Japan as well. And then with regards to the point raised by Wakikawa-san, whether or not we will be able to utilize 5.9 gigahertz. The key, I believe, is to release 5.9 gigahertz swiftly, which will accelerate vehicle-to-vehicle communication. And it's also necessary for the users to accept such connectivity. And then the manufacturers will be able to accelerate, I believe. Thank you. Wakikawa-san, did that answer your question? Professor Morikawa, please. So maybe Rei-san, maybe Wakikawa-san, or maybe somebody else. If you look at Japanese automotive industry and international other countries' automotive industry, there may be some difference. And Rei-san, you mentioned some slowness with regards to the development in Japan. How do you see the automotive industry in Japan? Rei-san, or maybe Wakikawa-san. Rei-san, please.
Yeah, so one of the interesting things is it's not always bad to be slow. You know, if you look at the global automotive industry, I think the biggest change right now happening is the adoption of EV. And of course, Tesla moved very fast, was the first mover, but I think they're already hitting a bit of a plateau, right? And in Japan, the Japanese players decided, you know, Toyota decided not to do full EV. And maybe that's not such a bad decision long term. So I think the technology adoption, you can only see success or failure after. It's really hard to judge success and failure before. So I would say it's fine the way it's happening now, but those of us who are in the technology industry, I think the key message is we need to move with the industry. So here we're talking about communication. The communication has to follow the speed of each industry, not the speed of communication. That is my recommendation. Thank you.
はい、我々もコネクティッドカーってことで、いろいろ日本の OEM 様ともやらせて。
Connected cars, yes, we have been working with OEMs in Japan as well. Perhaps automotive companies in Japan have too much technologies, adding too much value to vehicles themselves, and performance and safety, security of vehicles and sustainability of vehicles carry a lot of value. So without having connectivities, they can sell. In the past, when we discussed with connected vehicles, in order to collect information or data on defects or problems, and then recall can be immediately done. But Japanese-made cars do not break. So that is uniqueness about Japanese cars. And also among Japanese car manufacturers, the way we see them and the movement of them outside of Japan in the global markets are very different, because Japanese market is very small for them. Their main market has become global market. Therefore, their approach to the global market is very different. And their players are very different, and the services are very different from those in Japan. So maybe we have a lot of negative bias when we see the Japanese automotive manufacturers in Japan. Maybe that is the kind of a comment I can make. Yes, thank you very much. We talked about cars. Next, I'd like to talk about the trains, railways. Koide-san. Millimeter wave was adopted as a very successful case, was introduced earlier in your presentation. You mentioned that you completed development of this technology, but I thought that it would have been very difficult to develop this. So could you please give us your comment on this and what do you think about as your message to the world? Well, one thing that was difficult was when it comes to application of the technology to train or railways. Suppose that you may tolerate some disconnection of the communication network. Sometimes you may encounter, but for railway service, you needed to maintain the consistent service level, and you have to be reliable in offering such technology. So such technology that have been spread in the society will be utilized in order to create a system which can be also used in the railway application. That was very difficult part. Thank you very much. I enjoyed your discussion, but I know that the time is pressing, so I'd like to ask each one of you to give us your message. Koide-san, could you please first give us your message? You are leading the world. Could you please give us your message? For millimeter wave technology, which is not penetrating Shinkansen included and railway areas, we are developing and advancing the adoption of the millimeter wave technology. I hope that this will be spreading. Not only in the railway, but also could you please continue to lead us in the millimeter wave technology? Shibayama-san, please. Yes, we are talking about 5G as topic, not only in cars, but in many people from various industry sectors are participating. I know that there are various communication systems, but for 5G, whether such systems can be established utilizing 5G, it's something that you have to consider in the first place. Although there are various systems, there are other systems which are not used a lot. Then, therefore, when it comes to the effective use of the available frequency bands, promoting the usage of 5G, if there are any challenges or issues, then such issues will be addressed by the technology people. So industrial sectors and the technology development divisions needed to have an efficient loop of the feedback. Rei-san, please. Could I have your message?
First of all, thank you very much for this opportunity. I've learned so much today, and it's quite an honor. I think my final message is that Nokia wants to contribute to the development of the industry use cases and the ecosystem building. And this requires a lot of hard work, and we're ready to play our part, and we welcome all partners to work with us, and specifically to bring the communication area much closer to the industry requirements. And I will say the last thing is that in order to do that, we are actually talking far less about 5G and far more about specific industry requirements. Thank you very much.
ありがとうございます。それでは杉田さんお願いいたし
Thank you
ま
very
す。
much. Sugita-san, please. Yes. So I may be a little bit emotional, but operating company, the members of the operating company are almost all in their 30s. So Otani, baseball player, Mr. Otani's generation, it seems so that they have pessimistic image about the future of Japan. And another thing is that sustainability of the society is their focus. They see value in that. So that those people in that generation can be successful in the international market, and I think it is very important that we build a society for these people to be successful. So since I come from the outside of the telecommunication industry, you talked about the high quality telecom industry, but it seems as though that the reliability of telecom industry may be a little bit too high, which is a good thing. So from other people's perspective, people would say that there is a lack of reliability if we are to use cellular system for the navigation monitoring of drones. In the U.S., they try to use the network to manage drones. They want to use satellites, but in other countries, cellular, they can utilize cellular. So we do have that strength. So if when we look at those strength, we have the strength of the infrastructure as well as the strength of cellular. So since we have a global standard, this is a kind of technology that we can share. I think it is very important for us to develop an environment where young generation can be successful in this field. Wakikawa-san, please. Thank you very much for giving me this opportunity. As SoftBank, HAPS technology, we would like to push this technology, including standardization. And it's a very difficult challenge for us. Now that we are done with the communication standardization, we need to clarify the regulation related to airframe and others. So development of airframe as well as element development and commercialization, business model need to be developed. We would like to utilize the technology so that we can open up the world of stratosphere. So we believe that we can commercialize this in about 10 years' time. So hopefully SoftBank or even in the worst case scenario, a Japanese company could become a pioneer in this field. That is the kind of passion I have. And I'm looking forward to getting your support. Thank you very much for giving me this opportunity. Thank you very much for the powerful messages. Personally, when I was looking at my smartphone, 4G, 5G, and if it's not 5G, I start to worry that my communication is slow. So 5G is becoming popular and popular. Today we talked about land, sea, space, and ocean, and beyond a 5G related company, I do hope that you will work together in partnership to create the future for Japan. With this, I would like to conclude today's panel discussion. Thank you very much for your participation, and thank you to the panelists.